Stop recording. Button.
Just find maybe the rational solutions. So to be able to tell what numbers they particularly want, you'd have to know what numbers would be rational. Starting at the bottom, we have the natural or counting numbers, and those work with a nice, neat list. This would be the set 1, 2, 3, and ohm. Whole numbers are the same, but include a zero. Integers have a similar pattern, but continue in a negative direction as well. -1, -2, -3. And FYI, it's not integers, it's not TER, it's just TE. In the South, it kind of sounds like there's an extra letter. And then when we put all these together, we have the rational numbers. This is the set that we think of as fractions. And you may wonder, well, why is that set considered the fractions when integers, whole numbers, and natural numbers are also fractions? How can we make them fractions? Put them over 1. But the reason we call this set the fraction set is because we also include fractions like 10 over 17. Well, that's not going to fit any of these, is it? No. We're not able to list all the fractions. We're not even able to come up with a nice list that has a dot, dot, dot somehow. Therefore, we have to write them somehow with like a definition. Rather than a real formal definition, I've given a pattern of how to write them. If you have a rational number, the letters your textbook uses are P over Q. P's the numerator, Q's the denominator. When we write that numerator over the denominator, for it to be a rational number, the numerator P has to be an integer, and the denominator Q has to be an integer. So basically, if we have an integer over an integer, we have a rational number. If you think about the set of integers and pick any two numbers, one for the numerator, one for the denominator, then we have a rational number. You might choose an integer 100 over another integer -3. Would that be a rational number? Yes, that would be a rational number. There is only one exception. The denominator Q, the denominator in any fraction, in this case we have the letter Q representing it, cannot be what number? 0. The denominator in any fraction cannot be 0. There is no answer to that. If we have 10 over 0, 10 is an integer and 0 is an integer, but this is not a rational number because the denominator can't be 0. We say that it is undefined. Undefined in math means there's no definition, which means there's no rule for it. Math is nothing more than a game, just like you go to the store and buy Monopoly. That's all math is, it's a bunch of rules. And there's no rule for 10 over 0, or 12 over 0, or anything over 0. There's no rule for it. If you were playing a card game, and the joker was supposed to have been out of the deck, but it gets in the deck, shuffled, and ends up in your hand, what do you do with it? You toss it out, don't you? Well, that's the same as a number over 0. There's no rule for it, so it's just tossed out. There's no rule. The best memory clue I have for this is if you have a number on top, N for number on top, and 0 on bottom, what's N over 0 or N over O? If you think of that 0 as an O, which is not, you have the number over O, that spells what? No. So that's the best memory clue I can give you. What if it's the other way around? What if you have 0 over 10?
0.
That's equal to 0. I gave another example to show you how to check that if you just really get confused for some reason. If you have 30 over 5, what does that equal? 6. How do you check that? 5 times 6 is 30, right? So if you have 0 over 10 equals 0, you'll take that denominator 10, multiply it times your answer 0, and that should give you 0, which is the numerator. Now, back to up here on our chart. So rational numbers are integers over integers. Occasionally, those numbers will be disguised. If you have the square root of 100, that isn't even written as a fraction, is it? Much less an integer over an integer. However, if you take the square root of 100, you get 10, and 10 can be written 10 over 1, which is an integer over an integer. That means the square root of 100 is rational, because you can rewrite it as an integer over an integer. So that talks about radicals. Now let's talk about decimals. 0.5 is a terminating decimal. It can be rewritten 5 over 10 or 1 over 2, which means 0.5 is rational. 0.3 with a bar over it means that that 3 is repeating. What does 0.3 with the bar equal? It equals 1/3. It equals 1/3. So repeating decimals and terminating decimals are rational because you can write both as an integer over an integer. Now you may be sitting there saying, okay, are you telling me that 0.76 with a bar over both numbers, am I saying that you have to tell me what that is, integer over integer? No, I'm just saying that you need to know it equals some integer over some integer. Finding those integers is a different lecture. You probably had that maybe early elementary or maybe algebra 1 and might have spent maybe half a day on it. So it's not something that you would necessarily remember unless something happened that just made it stand out in your mind. So for now, all we need to know is that if it is a repeating decimal, that it will be equal to some integer over some integer. But we're not finding those numbers. English majors, did I ask that a while ago? Any English majors? Anybody like English? What does IR mean? And irrational, what does IR mean? It means not. So these are not rational. Not rational. It means they are not integers over integers. They are not radicals that work out perfectly. They are not terminating decimals. They are not repeating decimals. So what does that leave? They are decimals. They don't terminate. So that means the decimals keep going forever. But at the same time, they don't repeat. So they're decimal numbers that continue forever, don't stop, but there's no pattern to it. Like pi and square root of 2. They're both decimal numbers, but they don't stop, they don't terminate, and at the same time there's no pattern. So you may say, well, I thought pi was 3.14. Well, it is, because that's where we round it. That's just the start of it.
How many extensions are there now? You're talking about millions or something?
Yeah, more than that, I think, at this point, with computers. I have, this is an old sheet, this is probably 30 years old. Most of y'all already know. This is pi taken out to 1,000 places. 3 point, you can see the 1-4, and then 1,000 digits behind the decimal. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, almost 16 lines printed. And that's not the end, it never ends. You could spend your whole life writing pi, and that wouldn't be the end of it because it never ends. So it doesn't terminate. We had to stop it because it doesn't terminate, but do you see a pattern? Do you see like a 3 that keeps repeating? No, it looks like just a bunch of random digits. Did you have a teacher in high school or junior high who printed pi and put it as wallpaper border around the room? I ask that question every class because I keep waiting to have a class where nobody has seen that. It hasn't happened yet. Well, the reason they can do it is because they can print as much as they need. The number doesn't start. I will spare you that, however. This will work for us. Now, as just a side note, where does pi come from? Since you have made it this far, where does pi come from?
You need a little crust. That's old joke.
They didn't even
That's
class,
what
they
it
didn't
went
even
right over
class
their heads,
did
right?
that. We're in for a long semester.
A long semester. Everybody was like, yeah, it's over.
So where does it come from? Comes from a circle, there you go. You could do it with radius. Does anybody remember circumference equals pi times diameter? So if I solve this for pi, like if I get pi by itself, I'll divide by d, and I get circumference over diameter. So the circumference is the distance around, like the perimeter of something, it's the distance around. Diameter's through the center. And we've already said that pi is about 3.14. So that means if you have a true circle, the circumference divided by the diameter should be about 3.14. So go check your tires, I guess. See what happens there. Alright, so that pretty much takes care of irrationals. When we put all these numbers we've talked about together, we have the real numbers. And obviously, we can't make a nice, neat list of them either. We use a number line to illustrate this set. A number line is actually a real number line. Not because you can touch it or it's tangible, but because it is a picture of all the real numbers. Every real number has a place up here. You can see the natural, the whole, the integers. You can see rationals, and I threw in 1/2. Irrational, I put pi up there, but I just estimated where they were. What if I want to place the square root of 2 exactly where it is? And this is just an FYI. This is not something you have to know. what's the Pythagorean theorem? A squared plus B squared equals C squared. If A is one and B is one, those are the legs. Then we have 1 squared plus 1 squared equals C squared. So 1 plus 1 is C squared, so 2 is C squared. That means C is the square root of what? Square root of 2. Now, if I were being exact, if that leg were exactly 1 and that leg were exactly 1, then that hypotenuse would be exactly the square root of 2. And I could take that segment and measure it off on a number line, so that distance would be a square root of 2 distance. That's not something we will do. I just know some of you are going on past 112, and some of these little things might come in handy one day. And now we have imaginaries. They're not related to any of these we've already done so far as building on each other. So we've got the real numbers, we have the imaginaries. It's kind of like baseball and softball. They have alike, but there's a little bit that's different. With imaginary numbers, we are taking the even root. It can be a square root, a fourth root, a sixth root. We're taking the even root of a negative number. The even root of a negative number. So if I have the square root of 36, it's not 6, because 6 times 6 is positive 36. It's not negative 6, because negative 6 times negative 6 is positive 36. And it can't be one of each, 6 times negative 6, because that's not what a square root is. Well, this introduces a whole different type number, and this is actually what our first lecture will be on, 1.6. And this gives you a little insight into it. If we break down, well, let's start off with the square root of negative 36. If we rewrite that as negative 1 times 36, and then write it as 2 radicals, the square root of negative 1 times the square root of 36. The square root of negative 1 is I. The square root of 36 is 6, so that answer is 6I. Now you may say, why is I the square root of negative 1? Because it is. Like pi is the letter that was chosen to stand for 3.14. Okay, I is the letter that was chosen to stand for the square root of negative 1.
Does that mean imaginary?
Not really, but you can think of it that way. I mean, you know, it is imaginary, so. When you're taking this quiz, so far as an example on this one, if you want to do the square root of negative 36 or the square root of negative 2 or the square root of negative 100, that's fine. If you want to do 6i or 25i or 2i, that's fine too. You won't be expected to do this work in between, so you may choose which of those forms you like, doesn't matter. And finally, we put all this stuff together and we have the complex numbers. The pattern, which means it's not an example, but the pattern is a plus bi. An example would have numbers in there. A plus bi. A is the real number part, I is the imaginary, and B is like a coefficient in front of that I, A plus bi. So one example could be 4 minus 3i. 4 is A, B is negative 3, and then times I. You were frowning at me?
Hmm.
Are you frowning?
No, I was just trying to
Okay,
take it all in
okay,
this far.
Alright, so what if you have just an imaginary part? What if you have 6i? Well, if you have 6i, that means the b is 6. What is a?
0.
A is 0 because there was no real number there. 0 plus 6i would be equal to 6i. What about the real number 10? Well, that means there's no imaginary part, so that would be 10 plus 0i. B would equal 0. Now, do you see any questions that you might have? You want to list the sets of numbers, make sure they're spelled correctly, and then how many numbers do you want to give as an example?
1.
No, she said 2 across there from,
Oh, is it 2?
no, it's not, it's 1, that's why I went 1. Okay, 1 example's all you give.
So on the quiz, we gotta give an example too, not just
A
fill in
number,
the holes.
yeah, a number example. Just one number. I grade about, 150 papers or so. I don't wanna grade a whole set of numbers. I'm being selfish.
So like for
Just
example,
one number.
like for the natural encounter numbers, we can just say 1.
Yeah.
Yeah.
Okay.
So it could be 1, 1, 1.
Oh, now that's lazy.
And then
No.
there's 3
I
plus,
did not-
and then
I
there's
did not
1.
expect that
So
from
for
you,
whole-
James.
And then
So
there's
the
5,
whole number-
and then there's negative 36 squared, not squared, but
Rational.
rooted. And then 2 plus 5i. It's so simple. Takes
That's
about
what
3
they're
minutes.
fraction.
I did not expect that from you.
You know something? Should be an easy first test.
It should be. Everybody, they're 20 points.
It'll give
Quiz
them false
is 20
security.
points. Everybody should make 20, and most of the time, everybody does make 20. So, okay. All right.
I won't do that ever again.
No, I was laughing because in my other classes, I had said, now if you want to be lazy, you can do 5, 5, 5. Well, that was the first.
Yeah, it is great.
So that's why I was laughing. All right. We don't quite have enough time to get into that first section. If we start now, we'll kind of get at a point that'll be hard to stop. So for Tuesday, quiz is number 1. And then read and work as much as you can for 1.6. Let me make sure I have the right
What
section.
is
though.
1.6?
On your homework sheet, is it 1.6?
Yeah.
It is.
7271.
Okay. Now, just because you can't do number 15 doesn't mean you might not can do number 37. Okay, because there are different types of little problems. If you've never had imaginary numbers, don't stress out. But if you have, you should be able to get rid of it all.
Camera, stop recording.